Boom. All right, so we're here again to continue our discussion of topics pertaining to the CSEC mathematics syllabus. The topic under discussion in today's video is the topic of number bases. Number bases is one of those topics that a lot of people don't really like. I myself didn't like the topic when I was in school. Like so many other people who do in mathematics, number bases was one of those topics that I just kind of shift to the side and just move on with everything else. However, I believe though now, after years of interacting with maths, different topics, that kind of thing, I now have something that I could give back to people so that they wouldn't be in a situation that I was in when I was in Form 2, I think it was, when they did the topic of number bases. Alright, so I want to focus first of all on understanding what a number base is, explaining that, demonstrating, and then we will deal with the fundamental question of switching between different number bases. Alright, so as is almost always the case generally in life, if you're dealing with something, you need to know what you're dealing with. Alright, so if we're talking about number bases, we need to ask and answer the question, what is a number base? Now, I have thought about it a little bit based on my own experience, based on my own interactions with the people in mathematics. Alright, and I have come up with my own definition that is different to anything that you would see out there. But when I demonstrate the definition, you will understand why I chose to go this route. So it is a little different to what you would generally see, but I believe that this is a strong platform that will allow people to understand what a number base is, to visualize different number bases, and to then switch between number bases as the first step towards getting into the topic of number bases. Of course, there are other things when number bases is concerned, but we will deal with that a little later. So, my definition, and I'm going to read it out here. The base of a numeral system is that number whose successive negative integer, 0, and positive integer powers are summed up to give numbers with specific and unique values. Let me read that again. The base of a numeral system is that number whose successive negative integer, 0, and the positive integer powers are summed up, same difference, to give numbers with specific and unique values. Alright, there's a second paragraph here which I wouldn't read now, but a little later on we will talk about it. Alright, so what's this all this about? You read the definition, you hear me read it out, and your first instinct for most people would be to switch it off because you really can't understand or visualize what I just read out. And that is perfectly fine. It is my job, having written this out, having read it out, to explain it and make it simpler. So here we go. The first thing I want you to understand is that we already use number bases, and our use of it is so instinctive and so deeply embedded that we're not even aware that we're using it. Alright? It's almost like breathing. We learn how to do it and we just do it. Alright? We count in base 10. Alright? Let us start from there. We start with the number base that we count in. Alright, now there are different bases. 10 is not the only base, and the general explanation given for that is the fact that we have 10 fingers, 10 fingers, 10 toes. Alright, now I was going through my little research on the internet and stuff, and basically they were saying that throughout history, the most common bases that have been used are base 10, base 5, and base 20. Of course, 5, well, you have 5 digits on each hand. You have 5 toes on each leg. You have 10 fingers in total. You have 10 toes in total. And then when you add up the 10 fingers and 10 toes, you have 20 digits in all. So over the course of history, different number bases have been used to represent numbers. The most common base we use is base 10. And there are people now who are saying that base 12 is probably a better base to use, which, without having gone deeper into it, I wouldn't necessarily agree with, for the simple reason that the representation of decimals, based on my reading so far, is much more easy when you're using base 10. But that's a slightly different conversation. I'll just show that to you just for information. So what is base 10 about? Alright, remember my definition says that number whose successive negative integer, 0, and a positive integer power. So let me break that down first. Successive mean one after the other. Alright? Negative integer, minus 1, minus 2, minus 3, going down the road. 0 will always be 0. Positive integer, 1, 2, 3, going up the road. So if we are saying that the base of a numeral system is that number, whatever that number is, in this case, we're starting with that number being number 10, whose successive powers, negative integer powers, 0 powers, and, well, the 0 power, and the positive integer powers are summed to give numbers, then let me demonstrate it. Alright? Now, we know from way back when that in primary school they teach us the representation of numbers as units, tens, hundreds, thousands, etc. We know that. We know that. That is something that everybody know, even those among us who for whatever reason didn't finish school and we didn't pass maths and all this kind of thing. We know that. We know that. Alright? So let me write it out. So you have units, right? You have tens, you have hundreds, right? And you have thousands, right? In the interest of space, we'll stop at thousands because after that is tens, thousands, etc. This is for any number greater than 0, right? Or greater than 1. But we have fractions now. And we generally, when we're using fractions, in other words, we're using the we're using the base 10 as the number system. 10 is the base 10 is the number system. We also refer to that as the decimal system. Alright? Now, we use the word decimal when we come in on this side, where we actually take 1 and we divide it into fractions. So on the fraction side of things, watch it now, we have tenths, right? We have hundreds, and we have thousands, right? Blah, 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 right? So this is our number system that we are so familiar with that we don't even think about it. So this is it represented in words, and I'm going to do a couple examples and then switch to powers. So if I want to represent the number 123, for example, we know that 123 is 3 units. Sorry, let me change the color of the ink here. We know that it will be 3 here, 2 here, and 1, which is 3 units, 2 tens, 100. If I want to represent the number, let me say 4,385, we know that it will be 4,000s, 3 hundreds, 8 tens, and 5 units. So the very enunciation of the word tells you what the value is. Excuse. Now that is not always the case, especially when they use different bases, but we start with base 10 here. Alright? Let us switch now to decimals. If I want to say 0.439, right? We say 0 here because it's 0 units, right? We put a point here to signify that we're going in the opposite direction, and we now going into the realm of fractions, where we have less than 1 and we divide 1 into fractions. So 0.439 would be 4 tenths, 300ths, and 9 thousandths. So this is 4 tenths of 1, this is 300ths of 1, and this is 9 thousandths of 1. Alright? So you see how we're developing it here. And if I want to say, let us say 12.86. Alright? So 12.86 would be, let me say 2 units. Let me say 32.86. Right? Let me make life value more interesting. 32 points, and then you have 86. So 32.86 is composed of 2 units, 3 tenths on this side. On this side we have 8 tenths, 8 over 10, and then you have 6 hundredths, 6 over 100. Alright? So this is what we are accustomed using when we're talking about number bases. Now, what is the relevance of this when we're talking about powers? Alright? When we're talking about powers, this is what happens. So instead of saying units, I can write this over, and I'm going to deliberately rub it off and write the other thing just to make the point. Instead of saying units, I could write this as 10 to the power of 0. Instead of saying tenths, I could write this as 10 to the power of 1. Instead of saying hundredths, I could write this as 10 to the power of 2. And instead of saying thousands, I could write this as 10 to the power of 3. On the other hand, when we're talking about fractions, instead of saying tenths, this is where life will get interesting now. I could write 10 to the minus 1. And instead of saying hundredths, I could write 10 to the minus 2. Instead of saying thousands, I can write 10 to the minus 3. And that is why in my definition, where I refer specifically to, listen to it now, I refer specifically to negative integer, that would be these fellas here. 0, that is this specific fellow here. And positive integer powers of that number, in this case that number being the base of the number system. That number is 10. So you have the 0 power of 10, negative integer powers of 10, positive integer powers of 10. And every single number that we use in base 10 is made up of some combination of these fellas on top here. Alright, now I'm going to explain that in the next video in this series. Right, I'm chipping up the video small so that it wouldn't be too long. People could focus on it, take a little rest, and go back again. Alright, so in the next video to come after this one, I will basically expand on this using these same numbers here, and then following that we will use this as the platform, as the foundation, as the springboard to now switch to other bases. So we start off with what we know, we start off with what we're using already, and then we delve off into other things. We start off with base 10, and then we can start to talk about base 5 and base 3 and base 2, base 16. We could do that too. Alright, but let me don't jump too far ahead. We're going to deal with this in the next video and continue further.